Now, some of you may be wondering how those weather balloons actually work and what it could mean for forecasters right here in our area.
Meteorologist Chris Mulcahy is here to help raise our weather IQ.
And here it is. Look at this thing. This thing's giant, and Larry has shot one of these off before. It's bigger than you. Like, seriously, these things are absolutely huge. So let's raise our weather IQ, exactly what a weather balloon does. Well, first off, you see a lot of these maps. These are all model driven, but we actually need more information than that. We don't need what's just on the surface. We need thousands of feet up in the atmosphere, up to anywhere from 18 to 50,000 feet, where some of those thunderstorms can get that tall. So we need to know the information that's happening with all this. So what to know about a weather balloon? First off, when it's shot up into the air, it observes temperature, wind, relative humidity, dew point, and pressure up above the ground. Now, weather balloons also carry an instrument called a radiosonde, and here's what that looks like. So if you ever find this, it'll just say harmless weather instrument, and you can recycle these. So it's a recyclable. Those are the devices that are going to measure all of this data, and it happens twice a day. So the National Weather Service in Charleston, South Carolina, and also the one in Greenville, Spartanburg does the same thing. It's 7 a.m. and 7 p.m. Eastern Daylight Time that this is going to be shot off. Now, our weather balloons are simultaneously launched in 91 other NWS offices across the United States. So these are happening all the time, twice a day, and sometimes thrice, 3 times, depending on the atmospheric conditions. So if there's going to be a severe weather breakout, a lot of these offices will do an extra one to see what's happening. So here's an example. This is where we get into complicated meteorology. This is a hodograph. This is technically called a skew-T log P diagram. But all you need to know is it's tracking temperature as it goes up with height, tracks that dew point, and also the change of wind. So I'm going to show you an example of what a severe weather example looks like. This area, all you need to know is that's instability. The bigger this is, the more unstable the atmosphere. And whenever you have winds, notice how they're coming from the south and then out of the southwest. That's wind shear. That means it's a rotation of the atmosphere. So this is a very valuable tool for us forecasters that are going to pinpoint exactly what could happen. Also, it can tell what the environment is. If it looks like this, that means that, hey, it's going to have what's called a cap where storms can't break. But if it changes throughout the day, then it's an uncapped environment, and that allows storms to freely strengthen and rapidly produce. So it's a very valuable tool for us. We have other ones, but it really gives us the now, the insight, what the atmospheric conditions, let's call it the recipe for the day is, especially for severe weather events.
1,800 are released worldwide. So
1,800?
Yeah,
wow.
Twice a day, yeah. So it's pretty amazing. I remember as a kid finding one of those little radios.
You found one?
Yeah, because from the balloon,
Yeah.
it was a little cardboard package.
Oh, cool.
I kept it, and for years, I don't know what happened to it, but then I saw this, it needs to be returned. Back in those days, you had to send it back and had an address on it.
Yeah. Really?
Then I hid it, didn't tell anybody about it.
Larry Sprinkle.
It was funny is nowadays they actually say just recycle them.
Okay.
Yes.
Right.
Well, yeah, I was recycling.
So you're good now? Yeah.
That's what you did.
That's
As a 10-year-old kid. All right, let's recycle the weather wall.